Hello students, how are you all? Okay, nice I think. Okay, in last video we have discussed the first topic of electric charges and fields. What is a charge and what is the difference between charge and mass? We have discussed in last video. Now another important topic here it is, what are the properties of charges? The charge యొక్క ప్రాపర్టీస్ ఏంటి దీని గురించి మనం డిస్కస్ చేద్దాం. In first, the first property is charge is transferable. And the charge can be transferred from one body to other body. And this concept is based upon methods of charging. Charge can be done by induction, friction and conduction. Like this they have three methods. Okay, in our chapter we need not to study all the things. Only the thing here it is how the charge can be transferred. The first property we have to discuss here it is charge is transferable. Charge is transferable. The charge can be transferred from one body to another body. That is one of the important topic here. Okay, charge is transferable means if a charged body if a charged body is in contact is in contact with another body okay, if a charged body is in contact with another body, then the charge is transferred. Then the charge is transferred. Charge is transferred to another body. Charge is transferred to another body. That is one of the property here. Another body. This is one property. And this property is basically on the methods of charging. అంటే ఛార్జింగ్ మెథడ్స్ కొన్ని ఉంటాయమ్మా. ఆ మెథడ్స్ ఆఫ్ ఛార్జింగ్లో మనం దీని గురించి డిస్కస్ చేస్తాం. అదంతా మనం ఇక్కడ డిస్కస్ చేయాల్సిన అవసరం లేదు. జస్ట్ ఛార్జ్ ఎలా ట్రాన్స్ఫర్ అవుతుంది అనేది ఒక ప్రాపర్టీగా మనం ఇక్కడ తీసుకోవచ్చు. అంటే ఎలా అవుతుంది, ఒక చార్జ్డ్ బాడీ ఈజ్ ఇన్ కాంటాక్ట్ విత్ అనదర్ బాడీ. ఓకే, then the charge is transferred to that body. Okay, that is one of the property here. And the charge is always associated with mass. అంటే కంపల్సరీ ఛార్జ్ ఉంది అంటే కంపల్సరీగా దానికి ఏముంటుందమ్మా, మాస్ విల్ బి దేర్. ఓకే, వెన్ వితౌట్ మాస్ ఉండి ఛార్జ్ లేకుండా ఉంటాయి అనేది మనం ఆల్రెడీ లాస్ట్ క్లాస్లో వీ హ్యావ్ డిస్కస్ దట్. బట్ హియర్ ఈస్ ఛార్జ్ ఈజ్ ఆల్వేస్ అసోసియేటెడ్ విత్ మాస్. మీన్స్ ఇఫ్ ఛార్జ్ ఈజ్ దేర్ డెఫినెట్లీ ఇట్ విల్ హ్యావ్ ఎ మాస్. దట్ ఈస్ వన్ మోర్ ప్రాపర్టీ వీ హ్యావ్ టు డిస్కస్ హియర్. మీన్స్ if charging will takes place, if charging the mass is changed. The mass can be changed because of charging. That is one more property here. Means when a body is given a positive charge, then its mass decreases. How means, here suppose if there is a body, okay, there is a neutral body or there is a body. In this we take one electron. Means here we have bring one electron here. Okay, దాని అర్థం లాస్ ఆఫ్ ఎలక్ట్రాన్ అని. అంటే here this body is losing one electron. When this body is losing one electron, then it becomes a positively charged body. Then it becomes a positively charged body. And this body whose mass is decreases. అంటే ఇలా కనుక అయితే అంటే ఒక బాడీ యొక్క మాస్ డిక్రీజ్ ఎప్పుడు అవుతుందంటే దాంట్లోకి వెళ్ళి ఎలక్ట్రాన్ లూజ్ అయినప్పుడు. దట్స్ వై హియర్ దిస్ మాస్ ఈజ్ డిక్రీజ్డ్. మాస్ ఈజ్ డిక్రీజ్డ్. Mass is decreased. That is one more concept here. Suppose if another one, if a body gains electrons, means suppose if this is one body is there which gains some electron, then this body becomes a negatively charged body. Here what happens? Mass is increased. Mass is increased. These are the two properties we can observe here. Means when a body losing one electron, it becomes a positively charged body and whose mass is decreased. When a body is gaining electron and a gain of electron, here gain of electron will take place. When a body gains some electron, then its mass is increased. When a body loses electrons, its mass is decreased. That is also one of the property here. Okay. And next, we can take one more property. What is that property here is charge is conserved. Charge is conserved. The charge is conserved means constant. Charge is neither be created nor be destroyed. The total charge of an isolated system is always a constant one. That also here we can observe here. Charge can neither be created nor be destroyed. Okay, the total charge of a system is always a constant one. Okay, nor be destroyed, but can only be transferred. From one body to another. From one body to another. The total charge one body to another. The total charge of an isolated system is always constant. Okay, this is what we have observed here. That is one of the property here. What is the next one? The charge is invariance of charge. What is the meaning of invariance of charge? Charge does not change with its velocity, with its speed. Charge do not vary. With speed. The speed మారుతున్న charge అనేది మారదు. Okay, that is also we can have. But mass can vary with its speed, whose speed must be nearly equal to speed of light. That also one more property here. quantization of charge. Another one is quantization of charge. Quantization of charge. Charge can be quantized. What is the meaning of quantization? Quantization means discrete amount. Discrete amount. Discrete amount. Discrete amount are not continuous. Not continuous. అంటే కంటిన్యూస్గా ఉండదమ్మా. డిస్క్రీట్ ఫిక్స్డ్ అమౌంట్. ద minimum charge that can flow is charge of an electron. Charge of an electron. That also we will write here. The smallest amount of charge. The smallest amount of charge. The smallest amount of charge that can exist. That can exist independently is the charge of one electron. The charge of one electron. అంటే ఇండిపెండెంట్గా the smallest independent charge is charge of one electron. The charge of one electron is 1.6 into 10 to the power of minus 19 coulombs. Okay, 10 to the power of minus 19 coulombs. That is what we have, the charge of one electron. And this we are calling it as fundamental charge. దీన్ని మనం fundamental charge అంటాం. Fundamental charge. Like this we have different properties are there. Okay, quantization of charge. చార్జ్ అనేది ఎక్స్ట్రాగా క్రియేట్ చేయలేం. అంటే ఒక సిస్టమ్ కనుక తీసుకుంటే, ఒక ఇఫ్ యూ కన్సిడర్ ద టోటల్ సిస్టమ్, వాట్ ఎవర్ ద చార్జ్ ఈజ్ ఇంక్రీస్డ్, ద సేమ్ అమౌంట్ ఆఫ్ చార్జ్ కెన్ బి అబ్జర్వ్డ్ హియర్. అంటే దెర్ విల్ బి నో క్రియేషన్, నో డిస్ట్రాయ్ విల్ బి టేక్స్ ప్లేస్ ఇన్ అన్ ఐసోలేటెడ్ సిస్టమ్. దట్స్ వై ద టోటల్ చార్జ్ ఆఫ్ అన్ ఐసోలేటెడ్ సిస్టమ్ ఈజ్ ఆల్వేస్ ఎ కాన్స్టెంట్ వన్. అండ్ చార్జ్ డస్ నాట్ చేంజ్ విత్ ఇట్స్ స్పీడ్. అంటే స్పీడ్ మారినా చార్జ్ అనేది అలానే ఉంటుంది. Quantization means the flow of charges from one body to other body is in about discrete amounts. They are about discrete amounts. They are not a continuous amount. That we will discuss here. Okay, first you write this one. Okay, first you write all this one. Shall I rub this one? Okay, I will rub the one point. Here charge is always exist. Charge is always exist in fixed region. Charge is always exist in fixed region or in integral multiples. Integral multiples. Charge is always exist in integral multiples of fundamental charge. Integral multiples of fundamental charge means how it will be means Q is equal to Ne. Q is equal to Ne, where we can write Q is equal to Ne, where n is nothing but integral multiples, that is plus or minus 1 plus or minus 2 so on, like this. అంటే దాని అర్థం, సపోజ్ ఇఫ్ n is equal to plus 1 or minus 1, we can write 1 electron. 1 electron is flowing, or 2 electron, 3 electron, like that. But 1.5 electron does not flow. 1.5, 2.5 అలా మనకు ఉంటుంది. అంటే పాయింట్స్లలో ఉండదు, ఏదొచ్చినా ఫిక్స్డ్ అమౌంట్స్లో మనకు ఉంటుంది. అంటే ఇంటిగ్రల్ మల్టిపుల్స్ ఆఫ్ ఫండమెంటల్ చార్జ్ ఇస్ నథింగ్ బట్ ఈ కదమ్మా, అందుకే that we are calling it as fundamental charge. Okay, this is what we have, charge. Like this we have different properties are there. Okay, these are about properties of charges. Okay, next. The next important topic here it is Coulombs inverse square law. Coulombs inverse square law. This we have to discuss here. What is Coulombs inverse square law? Suppose if I consider two charges Q1 and Q2, like this we have two charges, and these two are Q charges, Q1 and Q2, or we can say first charge and second charge, first and second charge, and these two are positive charges. If you can take positive or positive, two positive or two negative, or one positive or one negative, whatever it may be. Suppose if you take like charges, the force of repulsion is there. Two positive charges or two negative charges, what the force is repulsion. Suppose if you take unlike charges, one positive and one negative, there will be unlike charges, then it will be attraction of charges will take place. That's why here we have to consider this is what we have, force of attraction. Here we observe it. Suppose here this one is F12, means force on first body due to second body is in this direction, and here F21 means force of second body on first body is F21. This is force of repulsion, and the force is always exists along the line joining the centers of two charges. That we have to see here. Okay, force is along the line joining centers of two charges. That is what we can observe here. Okay, force is along the line joining the centers of two charges. And how the charges are there? The charges మధ్య attraction force ఎలా ఉంటుంది అనేది ఇక్కడ మనం చూద్దాం. The force is along the, ఇక్కడ force ఎలా ఉంటుందమ్మా? Force acts along the line joining the center of two charges, this is what we have a center, this is what we have a center, and the force acts along the line joining the centers of two charges. Okay, like this. That is what we have, two charges. That is also we can observe here. Okay, first you can observe here. What is this one here? The force of first body due to second body must be equal to the force of second body due to first body, and these two are equal and opposite forces. But here you have to consider the magnitudes. If you consider the magnitudes, then it will be F12 is equal to F21. Suppose if you consider the magnitudes, the negative sign is not there, and only we have to consider about the charges, the forces between two charges, and how the force is there. According to Coulombs, he says that the force of attraction or repulsion, whatever it may be, it must be proportional to the product of two charges. Means it is directly proportional to the product of two charges. And the another, if products is more, if you multiply these two, whatever the product you will get, if the product is more, the force of attraction is also more. And suppose if this force of attraction or repulsion is, this is what we have a distance, and it is inversely proportional to square of the distance. If you consider this as r or d, whatever it may be, ఈ రెండింటి మధ్య డిస్టెన్స్ r అనుకుంటే, this force of attraction or repulsion is directly or inversely proportional to distance. Okay, and f is proportional to 1 by r square, or f is inversely proportional to r square. Okay, these are the two definitions, these are the two laws, or we can say Coulomb has derived from different experiments, and finally he concluded that the force of attraction or repulsion between two charges is directly proportional to the product, and inversely proportional to the square of the distance between the two charges. If you join these two, then what you will get? F is proportional to q1 q2 by r square. Or if I remove this one proportionality constant, then I place a constant k q1 q2 by r square. Okay, q1 q2 by r square. Okay, this is what we have Coulombs law. And this k we are calling it as proportionality constant, and k depends upon the medium. Okay, the medium which we have taken, suppose actually the k value is 1 by 4 pi epsilon naught, where epsilon naught means we can say it as permittivity. This we are calling it as permittivity in a free space. Permittivity in a free space. Permittivity in a free space. And the value of k is 9 into 10 to the power of 9. Okay, the value of k is 9 into 10 to the power of 9 in air or vacuum. అంటే ఎయిర్లో కానీ వాక్యూమ్లో కానీ దీని వాల్యూ ఎంతమ్మా 9 into 10 to the power of 9. And epsilon is the permittivity in a free space. Okay, like this we can finally conclude the value. And here if I want to write f is equal to 1 by 4 pi epsilon naught into q1 q2 by r square. q1 q2 by r square. This is about Coulombs law. Okay, 1 by 4 pi epsilon naught q1 q2 by r square. దీన్ని మనం Coulombs law అంటాం. Why we can call it as Coulombs law is inverse square law? Because you know that here we have written f. Suppose if f is, what is the relation between f and r? The relation between f and r is inversely proportional. F is inversely proportional to square of the distance. Suppose if r is doubled, if distance is doubled, if distance is doubled, what happens? If distance is doubled means if r dash is 2r, if r dash is 2r, then what is the value of f? If r dash is 2r, then the force is, how much the force? It is must be 1/4 of the force. That is first one. Suppose if r is half, ఒకవేళ r వాల్యూ హాఫ్ అయింది అనుకో, r dash is r by 2. If r dash is r by 2, then f dash is 2f. Okay, this is also for 2 marks we have this one. అంటే r distance డబుల్ అయితే ఫోర్స్ 1/4 అవుతుంది, r distance హాఫ్ అయితే ఫోర్స్ డబుల్ అవుతుంది. Okay, that is what we have Coulombs inverse square law. Coulombs inverse square law. Finally, what is the statement of Coulombs inverse square law? Coulombs inverse law, the statement is the force of attraction or repulsion between any two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between the two charges. And the force must be always acting along the line joining the centers of two charges. This is what we have Coulombs inverse square law. Okay, finally I will write the statement. మీరేం చేస్తారంటే ఫస్ట్ ఇట్లా Coulombs inverse square law అని రాసిన తర్వాత స్టేట్మెంట్ రాసేయండి ఫస్ట్. ఓకే, you will write the statement. Just you write the statement. Afterwards you write all the things. Okay, Coulombs inverse square law statement ఏంది? The force of attraction, the force of attraction or repulsion, the force of attraction or repulsion between any two charges is directly proportional to the product of two charges product of two charges, and inversely proportional to the inversely proportional to the inversely proportional to the square of the distance square of the distance square of the distance between two charges, square of the distance between two charges. Okay, like this we can write. This is what we have a statement. Okay, first you copy this one, square of the distance between two charges. Okay, this is what we have statement of Coulombs law. Coulombs law statement, like this we can. And one more point if you want to write, the force is acting along the line joining the centers of two charges, Okay, this is what we have Coulombs inverse square law. We will write some limitations. ఇది కూడా ఒకటి రాస్తే అయిపోద్దాం. Just we have two limitations are there. What are the limitations? Limitations ఏంటంటే ఇక్కడ మనకు Coulombs law is applicable only for point charges. అంటే కంటిన్యూస్ చార్జెస్లో మనం Coulombs law అప్లై చేయము. We can apply only for point charges. Coulombs law applicable is only for point charges. That is, we have first limitation. It is applicable దేనికి అప్లికబుల్ అనేది? It is applicable to point charges Q1 Q2 ఇలా తీసుకుంటాం. అంతేగాని మనకు దీంట్లో కంటిన్యూస్ ఛార్జ్ డిస్ట్రిబ్యూషన్ ఉంటుందమ్మా, దాన్ని మనం లైన్ ఆఫ్ ఛార్జ్, ప్లేన్ ఆఫ్ ఛార్జ్ ఇలా అంటాం. అంటే ద చార్జెస్ మస్ట్ బి అలాంగ్ ఏ లైన్ ఇన్ ఏ ప్లేన్ ఆర్ ఇన్ ఎ క్యూబ్ లైక్ దిస్. బట్ హియర్ దట్ ఫర్ దట్ కేసెస్ దిస్ Coulombs law is not valid. ఓకే, అక్కడ మనకు వేరే లా వ్యాలిడ్ అవుతుంది. ఇక్కడ మనకు Coulombs law is applicable only for point charges. That is one more here. And another one, Coulombs law is valid when the charges are at rest. చార్జెస్ రెస్ట్లో ఉన్నప్పుడే Coulombs law వ్యాలిడ్ అవుతుంది. అది కూడా మనం we will write here. Okay, extended only to point charges, and it is applicable when charges are at rest. రెస్ట్లో ఉన్నప్పుడే ఆ చార్జెస్ మధ్య ఫోర్స్ ఆఫ్ అట్రాక్షన్ ఆర్ రిపల్షన్ అనేది మనం చెప్తాం. అండ్ ఫైనల్లీ హియర్ electrostatic force. What are the force between two charges is electrostatic force, and electrostatic force is a conservative force. That is also one of the application here. Okay, we need not to write, just you have to remember that one. Electrostatic force is a conservative force. What is conservative we will discuss in the different classes. We will discuss in the next class, but only here these are the two applications. It is applicable only to point charges, and it is applicable when the charges are at rest. Okay, this is what we have Coulombs inverse square law. Okay, first you write all the things.